All right, welcome to Chapter 11, Section 8, called Equations of Circles. This is for Integrated Math 1, Integrated Math 2, or IM2. So first thing you'll see when you look at your screen here will be a due date. I don't see that on my teacher preview, but you'll see it on your student screen. The second thing is the number of attempts. We always allow unlimited attempts on homework, tests, and quizzes. Number of questions just particular to this assignment. Grading policy is always best score, so whichever attempt is the best one is one you keep. Partial credit's always enabled, so if you answer 1 of 8 questions, you get credit for the 1 question or however many you answer correctly. Or there's partial credit within questions with multiple answers as well. So down here it says, please remember once you start your homework, you must finish it before you can work on anything else. That means once you click Start, down here in the bottom right-hand corner, you will see a Submit Assignment button. That's how you finish your assignments, is by clicking that button. And what it means when it says you can't work on anything else is the program is literally going to freeze all of your other assignments and even your resources until you click Submit Assignment. It's trying to leave this attempt open for you because not all programs let you have unlimited attempts. We do. So click that Submit Assignment button as many times as you would like. It's not going to necessarily change your ability to come in and improve your grade. So it'll save your place as well. So if you've already started to answer some of these questions and you're not done yet, it's okay. Still click Submit Assignment button. Okay, that way it doesn't lock you out of everything. That's a huge reason to click that button. The other big reason is that it'll affect the gradebook once you click Submit Assignment. Until you click that button, you or your teacher can't see what it's doing to your grade. It's basically frozen. So just good idea, always click that button. Down here we have explanation, example, and message center. So explanation tells you you're going to lose your question attempt because it's going to give you the answer to this question. So you're not going to get the answer and then get to come type it in. Example will give you an example of something very similar to what it is we're looking at. So here it says, the equation of the circle given below, identify the radius in the circle of the graph. Well, we need to know this equation here. So let's go ahead and write it in our notes. If you have your notes pages open, this should be on your notes pages already because you should have filled this out in class, or maybe you're filling it out right now. So this is the equation of a circle. And HK, that's our center. So this is our center. Unless I don't know how to spell center. So this is our center, HK. Oops. I wrote those backwards, didn't I? It should be X minus H. I don't know why I wrote X the other way. So it's H and then K. And make sure these are minuses in the equation. So if you see plus in your equation, like I see plus here, that means there was 2 minuses. So be careful about that. And this guy is the radius of the circle. So sometimes they'll show it to you squared. Sometimes they actually give you the number 25 like this, and you have to take the square root. Okay. So this is very important. You want to make sure you look at the background information and read through the explanation and, make sure you understand what it is they're asking you to do. Once you're clear, you can close this. You can open another explanation if you want to. Or you can message your teacher directly from this screen. It will attach a picture so we know where to come help you. All right, so let's go ahead and get started here. So now that I've already messed up my darn board a little bit there, writing it backwards, silly me. So it is already written in very nice form for us. So we have x plus 3, so x minus h. H is my first coordinate point. Remember, it should be minus. Since it's a plus, that means that it's a negative 3 that they put in there. And then k, I have y plus 5. So again, that means there was a double negative there. And then I have 16. So r is going to be the square root of 16, which is, that's an ugly square root sign. I don't know what I was doing there. There we go. That's a little better. Equals 4. So I have 4, and I have negative 3, and negative 5. So now I also have to graph this because they show me the graph here. So I'm going to put my center on negative 3 and negative 5. There we go. And then I'm going to go like this, and I place it at the center. And then I need to make sure that I give it a radius of 4. So I can count over 1, 2, 3. Oop, I counted too far. That's 1, 2, 3, 4. And I can drop it, and it will graph the rest of the circle for me. I need to make sure I pull it out so that it has a radius of 4. I could go to the right 4, to the left 4, up 4, down 4. I just need to make sure I'm going right, left, up, or down so I can accurately count that 4 spacing. Alrighty. So, next one. So the equation of a circle is given below. Identify the radius in the center. So now we're not given it in quite the nice form that we were given before, right? We need this form. And I'm actually going to erase a little bit of this stuff so that it's not in my way as much. Maybe I'll fix that real quick because it's bugging me. All right, so I just want to move some of this stuff because we're going to need to do a little bit of work on this guy to get it to where we want it to. Erased K a little bit there. All right, I'm going to switch my color up for whatever reason. So we have x squared plus 6x plus y squared minus 16 equals 0. So we're going to do completing the square on this one so that we can kind of see where what we need to do here. So we want to group variables, and any constants that are left over without a variable, we want to scooch those guys over to the other side. Just to kind of get this set up. So I'm going to add 16 to the other side. So we're going to have x squared plus 6x. And I'm going to leave a spot open because this is kind of how I like to do completing the square. So I remember there's something that I'm going to be putting here. Plus, y squared is already by itself. There really isn't anything to group there. And then we have 16. I'm also going to do a plus on this side. So if there was something to group with this one and I was completing the square, I would have 2 pluses on this side, meaning I would have to be adding both things that I'm adding to the left side to the right side. I'm only doing it once on this side because y squared is by itself. All right, so to complete the square, I'm going to take the middle term and divide by 2 and then square that. And that's what I put here and on the other side. Whatever I add to one side, I have to add to the other side. So this is, the square is complete, and now I can factor this very easily. So it's x plus 3 squared, because square root, and there's a plus sign because they're all plus. So I can very quickly factor that. That's why we're completing the square. So we're kind of taking a step back to factoring here. So, and then we have plus y squared. And what this really means is it's minus 0, like this. It was y minus 0 squared. Well, that's not going to change anything. So we still know what k is. It's 0 when we don't see it there. And 16 plus 9 is 25. So now I can easily go, okay, well, here is my h. My k is not there, but it just means it's 0. So I have negative 3. Remember, there should be a negative here, so that means it's a negative 3. And 0, that's my center. And then my radius is this is r squared, so I'm going to take the square root of that. So we had to do a little bit more work on that one to get it there. Oh, and I got to type these in. 5, negative 3, and 0. So I have negative 3 and 0. Click my circle, click on the center, and then drag it over 1, 2, 3, 4, 5. It's actually letting me go to the half marks, which was, I was getting a little confused when I was clicking, because usually it doesn't do that, but it was letting me go to half marks if I needed to. All right. So give the equation of a circle centered at the origin, passing through the point 0, negative 4. All right, so with this guy, oh, where did my eraser go? Eraser's too far away here. Okay, so if it passes through 0, negative 4, we kind of think about a coordinate grid on this one. I think that might help us a little bit, because we have a point, and it's centered about the origin, so its center is 0, 0, right? That's my h and my k. That's what it already told me. And then it passes through 0, negative 4, like this. So the distance here is going to be 4. I already have my radius. So we just need to kind of picture that. What's the description? What do they give me? How do I make that work with the information I have? So I already know my r, and I know my h and my k. So I can already start filling this in. It's going to be 0 and 0 and 4. That's an equal sign. Sorry, that got erased a little bit there. Well, when I have zeros, that means that I don't even see them. All I'm going to see is x squared and y squared. That's whenever we have it centered at the origin, that's what ends up happening. So we have x squared plus y squared equals, and I believe they're going to want us to do 4 squared, actually square it, which is 16. I don't know if they'd let you leave it as 4 squared. We can try it. I don't know if there's a particular reason to leave it 4 squared. Hey, let us do 4 squared. I think it would have also taken 16 just fine. I don't think it would have argued with you at all. It was just making sure that you understand how to find the center, which is 0, 0, and how to find the radius, which is 4. So it's just kind of making you practice that. All right, consider the circle centered at the origin and passing through the point 0, 9. Give the equation of the circle. So same thing. Now we just have 0 and 9, so it's the exact same idea. It's going to be x squared plus y squared. I don't necessarily need to go through that whole piece again. It's going to be 0, 0, but this is not going to be 4 anymore. Now it's going to be 9 squared, and I'm going to go ahead and go 81, because 9 squared is 81. So I already wrote the equation here because it was very similar to the last one. They just changed up my numbers a little bit, or my one number. It went from 4 to 9. For each point, decide whether or not it is on the circle. So for this one, they want us to test and see, would it actually equal 81 if we were to plug it in? We have xy and we have xy here. So if I'm looking at these ones, I have negative 8 squared, remember it's negative 8 like that, plus 17 squared like that. So I'd end up with 64 plus 17, and that gets me 7, 8, 9, 10, 11, 6, 7, 8. That guy works, because 64 plus 17 is 81. So yes, that would be on the circle. We're just testing real quick to see. So this one is going to be the same thing. It's just backwards. 17 squared. That's going to be the same thing. 8 squared. That doesn't change anything at all because I'm squaring the whole piece. So it's still going to be 17 plus 64. So that guy also works. This one is 0 squared plus negative 5 squared. Well, 0 squared is 0 plus 25, because negative 5 squared is 25. That does not work. That would only be 25. And down here I have 9 and 0. Oops. So 9 squared plus 0 squared. I forgot to put this around parentheses there for whatever reason. So I have 81 plus 0. Well, 81 plus 0 is 81, so that one does work. So we're just testing to see, is it in fact the correct distance when I plug them in. All right. So now we have write an equation of a circle with center 5, negative 9, and diameter 6. So this one's just testing our knowledge. Do we understand, the relationship between diameter and radius? And this is going, it says and radius or diameter in the title that I'm looking at on the notes page. So they might give you diameter like they're giving here. They might give you a radius. So you might just be able to write it straight out with the information they give you, or you may have to do a little bit of work there. So they're giving us a diameter. Remember, a diameter equals 2 radii. So if my diameter is 6, then all I have to do is divide by 2, and then I'll have 3 equals r. So my radius in this case is 3. And it's centered at 5, negative 9, so I have 5 here, and then negative 9. So this is going to be x minus 5. The minus doesn't change because it's not a double negative there. Remember, that's part of the equation. Plus y plus 9, because there is a double negative here. It's negative, negative. So make sure you're paying attention to that. Don't forget the squares on the end, because that will definitely get you marked wrong. And then we have our radius squared. So remember, this is 3. We figured that out. So 3 squared is 9. Woo! That's weird. Why did it turn? There we go. 9. Clicking 9 made my whole thing turn a little bit there. All right. Just trucking through these guys. Okay, so we're deriving the equation of a circle using Pythagorean theorem. So we need to decide the radius, what the center is, what the radius is. We need to identify these pieces, and then we'll start to see how are they related to each other using Pythagorean theorem. So the radius is this length here, right, from the center to the side. So the radius is 2 units. They told us that. We could also use this and go 1, 2, even though it's not in the circle, or it is in the circle. It's not part of the triangle, it goes past the triangle, that's still a radius. I can count it on any part of here. 1, 2, 1, 2. I can see that it's 2 units. As long as I'm going straight up, straight down, right or left, don't go diagonal because you'll get kind of partials here. That's not the same thing. All right, the center is 4, 5. So 4 and 5. So that's our coordinate for our center. Value of A is, so x minus 4, because I want to know from the beginning to the end how long it is. So this is x, the total length, and I'll kind of draw it so that you can see what I'm talking about. So I have the total length from the side of the graph here to the beginning of P, and then I have the end of P. Well, this whole length here is x. We don't know necessarily how long it is, but we know it's x units over to the right. This length here, we know that this is 4. Well, we don't care about these first 4, do we? So that's why we want to do x minus that 4, because x minus that 4 would tell us what that piece is there. So just kind of thinking through it real quick, making sure I'm grabbing the right numbers. The value of B, so now I have y, this is y units high, kind of looks like 6.5 maybe, but we don't necessarily know 100% yet, but it's x minus, y units to the top. So I want to know what just this distance is. So the first 5 units here up to this point, I don't really care about that distance of y, because y is the entire thing from the bottom to the top. That's what this coordinate means. I went up y units. So it's that same idea. I'm starting from the bottom of the graph here, and I'm going up y units, like this. But here is the bottom of my triangle, right here. They didn't give a label for that one, but that's that right angle there. And there, I know that this distance here is 5, right? So I don't want to know this distance. I want to ignore it. That's why I want to go y minus 5. So y minus 5. Okay. So now we're going to put that down here. Instead of a, because we have a squared plus b squared equals c squared, right? So a, they're asking me to substitute in x minus 4. And b, they're asking me to substitute in y minus 5. And then c squared is the radius, so that's 2 squared. So they're just showing us it's a squared plus b squared equals c squared. It's the exact same idea as Pythagorean theorem because we're looking at the right triangle there. We just can use that if we know the center. We can see here's 4, here's 5. Here's 4, here's 5. So it's just a way to relate these things. Where does it come from? All right, a couple more of these. It says, find an equation of a circle that has center, -1, 2, and passes through -2, -1. I wanted my eraser. Okay. So now we're not being given the radius or the diameter straight out. We're going to have to find that distance. I do know the center, so I know it's going to be -1 and 2, but I need to know the radius. I don't have that piece. So I'm going to need to know what is the distance from the center to this piece. So I'm going to have to use the distance formula here. So the distance formula is x2 minus x1 squared plus y2 minus y1 squared. So this is one of those big things with math concepts is we're very much so cumulative. We build up. We keep using things over and over again. And we haven't used the distance formula in a little while here, but that doesn't mean it disappears. We kind of keep coming back to these things and reapplying them and applying them in different ways. So the more we practice these things, the easier it gets, for sure. If we're not practicing them over time, then this is kind of as brand new every single time we see it. So it's one of those things that we definitely want to keep practicing. All right. So with this one, I have x2 minus x1. Remember, the coordinates always go in order xy, xy. Oh, my alarm's going off. And if you notice, I put the negative in here because that's part of the equation. So don't get rid of that just because it's a -1. It's a double negative, which is going to turn it to a positive. Then I have -1 for y2 and -2 for y1. So I'm just plugging them in. So now we're going to go through and start to simplify. So I have -2. This is going to be +1. So it's going to be negative 1 squared, because negative 2 plus 1 is negative 1. Negative 1 minus 2 is negative 3. So now I can square them. Negative 1 squared is 1. Negative 3 squared is 9. So now I have the square root is 10. So I have the distance from the center to the side where it passes through is the square root of 10. So that is my radius, is the square root of 10. I don't want to use any decimals. I don't want to actually find the square root of 10. I know it doesn't give me the calculator, so it's not expecting me to do that. What it wants me to do is square this. So this is the square root of 10 squared. Well, the square root of 10 squared is just going to be 10, because when we multiply them by each other, it gets rid of that square root sign. So I'm going to go ahead and type these in. So I have x minus negative 1, which is plus 1 squared, and then, plus sign, plus y minus 2, there's no double negative there, so keep the negative, equals 10. Alrighty. Last problem here. So we have find an equation of the circle whose diameter has endpoints for negative 3 and negative 2, negative 5. So now they're asking us to do two things. We're going to have to use the distance formula. I need to know how long this diameter is. And I also need to know the midpoint of this diameter, because I'm not being given the center. So I don't have either of the pieces that I need here. But I do have enough information to move forward. Because I'm going to use that distance formula again. Try to erase without messing that up too much. The distance formula will tell me how long the diameter is. Remember, a diameter is 2 radii, so I can just divide it by 2. And then I'm also going to have to use the midpoint formula, because that'll tell me where the center is. Because the diameter is 2 radii back to back. So the midpoint of the diameter is the center. So just kind of applying those rules that we've been learning about circles from the last, it's almost been a month now. All right, so I have x2 minus x1 squared plus y2, minus y1, which is negative 3. Boom. So don't forget those double negatives. That's very important, because it's going to change to a plus here, and that changes the problem a little bit. So then we have negative 6 squared plus negative 5 plus 3 is negative 2. So if you had forgotten to change that to a positive, you might get negative 8 there. So you want to make sure you're paying attention to that double negative issue there. So you end up with 36 plus 4. So we end up with 40. The distance of the radius, because this is the diameter, so the diameter distance, I know that's kind of funny, d equals d. Diameter distance is square root of 40. The radius distance is the square root of 40 divided by 2. So we know this part already. And we're going to square that, right? Because it's the radius squared. When I square that, it's going to be 40 over 4. Both get squared. So this gets squared and this gets squared. Both top and bottom. Since the top is in a square root sign, it just stays 40, but the bottom does become 4. Well, that 40 divided by 4 is 10. So we have part of our answer there. Now I need my other two pieces. So I'm going to go ahead and erase all of this. And we're going to do the midpoint. So for the midpoint formula, oh darn it, gotta click on my pen here. I have x1 plus x2 divided by 2. So that'll tell me the coordinate for x for the midpoint. And then y1 plus y2 divided by 2. So we add the x's together and divide by 2. We add the y's together and divide by 2. And that'll tell us our midpoint. So I have 4 plus negative 2 over 2 and negative 3 plus negative 5 over 2. So this is going to be 4 minus 2, which is 2 over 2, negative 3 plus negative 5, which is negative 8 over 2. So reduce one more time. 2 divided by 2 is 1. Negative 8 divided by 2 is negative 4. So here's my h and my k. My h and my k. So I can go ahead and start plugging these in. So I have x minus 1 squared plus y plus 4, because it's minus negative 4 squared equals 10. All right, so that was section 8. I will see you in section 9.